Hello, and welcome to the Observability Heroes. Today I'm going to talk to you about what else? OpenTelemetry. But that's kind of not OpenTelemetry in general, but how it helps avoid the vendor lock-in. And I'm going to take a look at what the vendor lock-in actually is, where it has come from, and what OpenTelemetry does about it. And why it's bad. Well, not per se, but it can be bad and limiting. But let's start. So, what is the problem that we're looking at and that OpenTelemetry helps to solve? Well, applications, services, and observability are constantly out of sync. When I was working for Wiley in 2003, Java, J2EE was all the rage. And that was like web services introduced, three-layer architecture. You had a front end, you had a back end, and you had the middle layer. But it was all monolithic. And after that, we had SOA, we had service-oriented architectures, which were, well, more diverse and more distributed. And we needed new technology to solve the issues that we had because of this new approach. So new technology was introduced, services, and now we had to monitor it differently than before. But that leads to a ton of new things that are released. So like in Java, we had the framework of the week for a while, and that had to be supported by the monitoring solutions. And if you were not up to change, then you kind of were out of date. But you may had already your users blocked in because they developed a lot of stuff that was proprietary, and that may change very hard and usually also expensive. So the wave of new technology that you use to deploy your applications, to run your services, to make your business work, also demands a change in or an update in observability. And roughly every 5 years, there's a new wave of things that is not so easily observable with the existing technology. Hence, we have a ton of different technology to monitor and observe stuff. Yeah, a lot, a heap of technology. And this is just a very small fraction of what's out there. Those are names of vendors and technologies and ideas or whatever. White paper, for example, from Google. And all that, when I put all the technologies on this slide, all the technologies around observability and vendor names, the thing would be completely white because it's a ton of stuff that's out there. And what does that mean? First of all, it's a ton of stuff. But the problem with this is that they were all developed one by one and one for one. They were not developed to interoperate, to share data. None of them was made for all of the others. So one for one, none for all. That means if I want to see my dependencies, my dependencies between the services, this usually relies on tracing. Tracing relies on context propagation, and this is done differently with all the vendors. All of them had their own way of doing things, and have their own way of doing things. The same with metrics. The naming, the calculation algorithms, methodologies, they can differ. Which means it's not so easy to compare metrics and put them on a dashboard with the same meaning, so to say. And then there's the transport layer. Data has to be transported from the agent, where the data is gathered, to the backend. Usually this happens via HTTP, but inside the HTTP traffic is something proprietary. A compression algorithm, a security-related thing. Every vendor has their own way of doing things, which makes it not easy to put it all in one place. That means we end up with a slow adoption rate. New technology and new approaches are not so easily adopted because you would need to change everything. If you have a big distributed system, you're not changing that from immediately from today to tomorrow. So that's what vendor lock-in actually means. You feel locked in because you cannot just change easily things, and your current vendor doesn't support stuff that you need to see it. And this means, yes, you are probably locked in. You're not feeling locked in, you are locked in. And that's because there wasn't a standard. But it was time for one. And it came with OpenTelemetry. There were standards before, like the W3C trace context. That was there, but nobody used it. Or implemented it not fully, or augmented it with stuff that was not compatible with others. So OpenTelemetry is changing that. If you like to know more about it, there is a video about OpenTelemetry, a game changer, which is also explaining a little bit what OpenTelemetry does. I'm not going into this detail here. I'm looking at the vendor lock-in. So what's the way out of the vendor lock-in? First of all, we need to have a standard. That's great, but we had it before and it wasn't adopted. That's the crucial part that happens with OpenTelemetry now. It is adopted. The vendors are embracing OpenTelemetry because it reduces their effort in implementing data gatherers. I'll explain that in a second. The maintainers of frameworks like Spring Boot or Flask or Kong or others can now finally put the instrumentation for the observability already in their code. Companies like Shopware do that, or Shopify. They write, so Shopware is in PHP, Shopify is in Ruby mainly. They provided most of their instrumentation for their applications, for their services already out of the box. It's actually really easy in Shopware to get the OpenTelemetry instrumentation. You just switch it on and there it is. The vendor of your observability solution doesn't have to do a thing. They are getting the traces and they're getting the metrics and the logs. And besides the frameworks, there is also the transportation layer. And that's a big thing for OpenTelemetry, that the vendors are embracing OTLP as a standard for transmitting observability data between the agents, collectors, and also the backends. So they accept OTLP. And that's great. And plus we have a collector architecture that's really scalable on the OpenTelemetry side. So this helps us to get out of the vendor lock-in. So changing the game. But what do I mean by that? Let's dive a little bit into the technology. So what you see here is a wall of text. It is actually an excerpt from a file called PBD, a Probe Builder Directive. Those of you who know Wiley Interscope will remember those little things. There were a ton of those. For each framework, for each OMR mapper, ORM, Object Relational Mapper, ORM framework or library, there was one of those. This one here is for Tomcat, and it will help us to count the active sessions in a Tomcat instance. And it does that by looking at the calls to the activate and passivate method of a certain package in Tomcat. And this called a proprietary method called method trace incrementer, which just counted a metric up by 1. Or it counted it or subtracted it with the passivate. The result was the number of active sessions. And you see a couple more lines here about JDBC store, save, remove, file storage, like the different pools that we had in Tomcat. You had to know a little bit about Tomcat to write those things. This was provided by Wiley at that time, so this came with Tomcat and you just had to activate it. But you can imagine that there was one such a file for each of the frameworks that were out there. And in the 2005, 2006, there were a handful of those. It was kind of overseeable. In 2010, it was not overseeable. There were so many frameworks, so many things out there that needed to be instrumented. So as a vendor, what do you do? Let me give you a little bit of an example what happened here. And that explains why the vendors are usually behind the tech curve. So something that's used out there in the market is not instrumented, not monitored until there's a big demand for it, because there's a lot of effort. So I take the example of Instana, the latest company I worked for. There's tons of frameworks and implementations out there. You wouldn't believe how many HTTP frameworks for Java alone are out there, and all of them are a little bit different. 50% of the developers, the developing power was invested just for maintaining the agents and the instrumentation libraries and the instrumentation configurations. There were also tons of enhancement requests. Like, can you support this framework? Can you support that framework? How to prioritize them? We need to focus on stuff that is really out there in the market. So we needed to find out what is really used, and then we could implement it. Sometimes it was done in a day. It was really easy. Sometimes it took a couple of months until you really found the key to have it get implemented thread safe, so that you're not blocking anything, that your instrumentation doesn't actually kill something in your application, and the customers waited during that time. And also the test cycles grew enormously, because all of that had to be tested to make sure we are not introducing any risk to a running production system just by updating one of these sensors. That is the effort that's behind it, and that's totally explainable why the vendors are then kind of locking you in, because they had to implement that. And the lock-in is a result of that, because they implemented it in one way, and for good reason, but it was not interoperable with the others. And that means, well, you are not free to change unless you use something like OpenTelemetry. An example of what actually needed to be done is context propagation. That's the most important thing in tracing. So what context propagation means is you connect the dots between the services. So you have service A calling service B, and you add this little connection piece, the correlation ID or trace ID, and that needs to be sent with the HTTP request, and it needs to be interpreted with the response. So usually this is done in headers. And you have to do this for each framework. You have to have an instrumentation, because sometimes these things are called invoke, others are called do post, do get, I'm speaking softly here, call, you name it. It's different for every one, and also the propagation of parameters, and especially headers, is different for all of these frameworks. So that means we had an implementation effort for all of those, and then you'll have things like called X standard trace, X in standard T, X in standard S, or singularity header. The latest is, who would guess it? No? No raised hands? The latest is actually AppDynamics. Singularity was the initial name of AppDynamics in 2007, 2008, and it's stuck until now. It's still Singularity header. That's what's propagated in the traces of AppDynamics. There is a standard from W3C, which defines trace parent and trace state, but that is not implemented by everyone, and most of the vendors added their own augmentation to it because they were not happy with what was possible to send along. And that's just for HTTP, which is the majority of cases, I'll give you that. But there is also MQ and other message systems that are not standardized in total. Some use the W3C context, some not, and you definitely have not headers. You need like properties, and you have the same implementation effort. There is a request response, a pubs up, so publication and subscribe, publish and subscribe way, and all of these frameworks need to be able to put the trace ID in and extract the trace ID so we can get forward. So let's take a look at that. There is an example service chain here. So let's say I have a service called getCard. That's what my endpoint is. And then the getCard calls getCustomer and getItems. They call into an inventory database and a CRM database, and also an ad service that's out there to get some promotions, for example. Now, there is a header X vendor that is propagated, and it's fine. Get card sets this header, and then get items is reading it, and therefore propagating the context, and then it sends it over to get ads. But get ads doesn't know what to do with it because they don't know the X vendor header. They would expect something else. They would be able to deal with a W3C context, but not with this X vendor. So in that case, the trace ends here. I can see they were calling get ads, but what happens after that is simply not visible. So there's get promo, we know that, but maybe this thing is calling external services as well, but we don't really know because, well, we couldn't follow the trace. Even if get ads is instrumented, it wouldn't help us. It would break here. And so we get not a full end-to-end picture. We get visibility into our database, into the database statements that we set, but not much more. This is what the problem of vendor lock-in is. You have to implement all of the vendor's technology in the complete chain, unless you like to live with blind spots, which you will have if you're not implementing it fully. And that's the problem. That's vendor lock-in. And it's a technical necessity. That's the problem with that. It's not a malicious intent on the vendor side. It's just they implemented something because there was not a standard. There is now, but to re-implement it is a major effort, and you wouldn't do that. So they're sticking with it, and it's working. And the idea, well, not the idea, but it is kind of a trade-off. You give the freedom of choice up, and you're getting the convenience that your vendor is doing everything for you. You just drop in the agent and magically shows you everything. Unless it's too much effort. And then things like Go come along. Go doesn't allow you to do an on-the-fly instrumentation. It has to be part of your development process, unless you're using eBPF, which is another thing. And this is just getting off the ground. So the vendor lock-in is not malicious, but it's a reality. It's there because of technical constraints. And that's the issue. And it's not only propagation, it's not only data propagation, it's also resource labels and attributes that are stuck to like JVMs that are running on a host, that are running in a pod, that are running on a node in Kubernetes or whatnot, and how to put the resource labels on it, how to put the host name, the node name on it, how to format that. Also infrastructure mapping, like, oh, this JVM is running on that node. That's not that easy. It's also implemented differently by different vendors. Security aspects, like what data to redact, what do I strip out, how do I configure that? The metrics, same thing. Naming and what metrics are pulled out in what format, and then log event correlation as well. Like how do I do that? It's a ton of stuff that is all vendor dependent and very, very much to it. And with OpenTelemetry, all of that is taken care of. The only thing that we need is a backend that is able to deal with this data. So that is the look inside why vendor lock-in is there. And let me just give you the little wrap up in a then and now. So we have a historical trade-off. We trade our convenience versus the freedom of choice of the vendors. That means we have a lock-in due to technical constraints. And it can result in a happy customer if nothing changes. It can result in high costs because lots of things are changing and your current vendor is not really supporting it, but it's costing you, therefore, a lot of money. Or you simply don't see things because your vendor doesn't support it. You need to change it, which is another cost factor. Now, we have now a standard, a technology standard that can be implemented, which reduces the effort on the vendor side. They don't have to implement all of these different instrumentations for the different frameworks out there. It supports it fosters the support of the maintainers and the contributors of frameworks, which is great because they know what the stuff does. They know the classes and methods and ins and outs, and they can put the ready-made instrumentation already in the code and you just switch it on, which some already do, and this is great. And that enables the freedom of choice of your vendor, of your backend. You can keep the ones you have, you can augment, you can send the data to another one in parallel, which is wow. And then you can decide what to do with the data. And with another game-changing thing in OpenTelemetry, which is the semantic conventions, we are almost there to be able to flawlessly switch the context, keeping our data, having total control over our data, and just switching the way we'll look at that. And yeah, that's kind of what I wanted to bring across. That's why OpenTelemetry is such a game changer in the whole field, and why it is helping to reduce the vendor lock-in. Again, the vendor lock-in is no malicious intent. It just turned out to be that way because of technical constraints, and we made that trade-off in earlier times because there was no standard. But we have one now, and we can switch over. That's it for now. See you next time when I talk about semantic conventions and what they do for us. And no, it's not boring. See you then. Bye, Rainer.